Hello YouTube. Alright, so I want to show you how to do merge sort in C Sharp. Okay, there are other options out there, but I want to show you how to do it in C Sharp. Alright, so I'm assuming you're already familiar with algorithms and that you already heard about merge sort, and you're here just to learn how to do it in C Sharp. Alright, so let's get started. So I already have the base uh, for this video. Right, so the first thing I wanted to mention is that I am running this in .NET 8. As of right now, this is the latest, and the reason why I'm mentioning this is because I'm using the spread operator to slice the list in half, and the spread operator works very well for this for the merge sort. If you use older frameworks, you may have an issue, so you may need to use probably skip and take instead of the spread operator. Just be aware of that. Um, but I'll I'll go over that. So first thing we're gonna do is we have our merge sort. So we have our method defined here, and we have a list, unsorted list, and this is the one that we're gonna be um, sorting. If you notice, it's 1 through 14, and this is just scrambled, and we're gonna sort that. So using divide and conquer, which pretty much what we're doing is we're just going to be looking at the middle point, and then we're going to be slicing uh, the main list in the middle, and then we're going to keep calling ourselves recursively. And every time we call ourselves, we will have a smaller. We will continue slicing in half and half and half until we reach to a single item array or a single item list, which and then we will hit our base condition, which this is what we need to have in order for us to stop the recursive calls. And whenever we return back, uh, we will unwind and we will start sorting um, everything by using a merge helper a method that we're going to be generating. So I have it right here, but we're going to be implementing that here. So first thing is first, I am going to, this makes sense. So we have a list, we're calling our merge sort here. We're passing our unsorted list, and we're gonna write console the results. Then inside our merge sort, we are writing to the console, every time we call ourselves, we're gonna be writing the list just to kind of see something similar to this, how we're splitting everything in half. All right, and we'll review that at the very end. And then we have our base condition. And then from here, we're going to continue. We're going to start working on the first condition for the merge sort, the first implementation. Sorry. All right, so I am going to copy and paste some of the code, and I'm going to review to make this video faster. So just bear with me. Let's copy that. I don't want this to be too long. And then I'll work through the helper. I'll write the method while recording the video. All right, so what I did here is I have a midpoint, and what I'm doing to calculate the midpoint of this array, so I'm just doing the length divided by 2. That will give me my midpoint, right? So the midpoint will fall around here, right? Because it's 14 items, so this will be my midpoint. So, and what I'm doing in this situation, I am creating a new list. I call it left partition, and then another list called right partition. And we're going to be calling ourselves recursively, uh, and we're going to be slicing the original list in half. And how do we achieve that? It's we use the list and we use the spread operator, which is uh, by adding the open bracket and then dot dot and then midpoint. And this pretty much what it's doing is just saying slice the list from the beginning all the way to the midpoint. Midpoint is 7, but not including the midpoint, right? So what it will do is it will slice the list in half. And when you call yourself recursively, now when you come back here, you're gonna have only this part with this number of items. Then you're gonna go back again into this condition, you're gonna get your midpoint again, and you're gonna slice it all the way until you get to a single item array, and that's you're gonna hit your base, and you're gonna return that. Then that is gonna pretty much place everything into this list. Then you're gonna do the same thing for the right partition. You're gonna slice it, but now you're gonna slice it on for the right side of the original list, or from the list, or the right side of the list. So you're gonna start from the middle point and then all the way to the end. So from the middle point all the way to the end. And then you're gonna continue calling yourself until you get to a single item array. And then every time you finish with once you're finished, you will place it in here, and then you will create a new sorted list array or list, and then you're gonna call your merge helper. And this merge helper method is gonna take your left partition and your right partition arrays, and then we are going to do a comparison. And then when we do the comparison, we're gonna compare the left with the right, and we're gonna order them to completely sort this list. So let's get started with this. So here, what we need is we need to declare some left index variables, and we assign that to 0. We're gonna use this because we're gonna be looping through the left and right list. Right index 0. Then we're gonna create a sorted list that we're gonna be returning. So list int sorted list equals new list int. Let me just put that here. We're gonna do a while loop. While, let me just get all this. This tool is not very good. So we're gonna do a left. We're gonna do a comparison while left index is lower than left partition that count, and right index is lower than right partition that count. Then we loop. Now inside this loop, we're gonna check for the values of we're gonna compare the values of the left list and the right list. So we're gonna do if left partition and left index are lower than right partition at right index. If the values on the left are lower than the values on the right, then we do sorted list. We add that to our sorted list. So since the left are lower, we want to sort lowest to highest, we're gonna add the values from the left. I should just type this left p left I else, oh, one more thing, then we're gonna increase the index of left I. We're gonna increase that by 1, else we're going to do the same thing, but we're gonna do the other side. Well, let's just do it. Sorted list add, and we're gonna do right p right index, and then right index, we're gonna increase that. And this is what's gonna help us, with the while loop to stop it. Once this is not true, then we're gonna exit out of the loop. Now we're not done yet. There's another condition that we have to really, really pay attention to. So let me give you a scenario I found out the hard way. There are some times where when you're gonna have, when the list that we're passing here, the left index, the left array is gonna have like one item. This is just a scenario, and the right one is gonna have, let's say, 3 items. Okay, so when you loop through here, the first condition is gonna go just fine, right? It's gonna go fine. But then this one, since we're gonna increase that one on the right, and this one only has the length is only 1, we are not gonna be able to go into this loop again. So that means that we're gonna have 2 values, or maybe potentially 3 values, or whatever values left without any checks. So we're only gonna sort them, the just the ones that we're able to loop in here, but the remaining values are just gonna be hanging in there, hanging there. And we're not gonna have a complete sorted list. So in order for us to take care of this, we will have to loop through the remaining of the values on the array until we completely sort everything. And how do we do that? Is we just simply loop through the remaining values just by doing this. And that's the, and then here we are going to remove, so we're just gonna take it to the left. And so one while loop is for the remaining of the left, and one loop is for the remaining of the right. And here we are going to repeat the same steps we're doing here, because if you notice, this is what we need to do here. So we'll fix the formatting right now. There you have it. All right, and then at the end we return a sorted list, which is this one over here. And that should take care of everything. So why do we have to do this? Like I said, if the left has a length of 2 items and this one has a length of 3 items, the right one, we're just gonna loop until one of them, because we're using an AND condition. It's if this one, the left one is gonna reach its end, and the remaining, this one is still gonna have values. So we're gonna stop here, and then we're not gonna have everything accounted for. But if we continue, once we're done with this, and then we still have values on the right one, so what's gonna happen is that this one, since we're already done with the left, and it's the same condition as here, we're not gonna go into this one because we're already done with this condition. And then we're gonna go check on the other one. This one still has a larger, this condition is still met, so we can still go in, and we just continue adding the remaining values into the sorted list, and then we call back and we continue calling ourselves until we have a completely sorted list. But take a look at this method, take a screenshot, pause the video. This is the method. Now let's run a test. So right now we're gonna run it. And we got 14 items. So let me just add one more value. And you may think it's not working, but look, we're 1 through 100. We can do 500, 500, 555. We can do 200. We can add a 150. And if we run it, it will all be sorted in the right way. So 1 through 14, everything in order. So the sorting algorithm is working. I like to keep it short so you can make sense of this. We can easily look at this. So if we really pay attention to this, this is what we're doing. Um, this is the full list. We're using the first half, and then we half it again. Then we, from this list, we half it again. We get number one item array. Then we still have the remaining. We half that. We have one item. Then we have one item. Then we move on to the next part, which is this part over here. And we do all the way until we get one item arrays. And then we work on the other half, which is the other half. And then we repeat the same step, half, 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 until we're completely done, until we completely sort everything. So, like I said, go into Visual Studios, put a breakpoint, and play with this, and just try to understand it. I really hope this helps. All right, so thank you for watching.